For questions 7 and 8 here, they give you the data set as well as the stem and leaf that would go with the data set. I didn't really have enough room on my board to write out the whole data set, so I'll be referring to it, but it is included in the question on Cengage. So question 7 says a stem and leaf is given below. Here they show what the stem and leaf looks like, but before they give us all the data points. All the data points are single digit numbers with then a decimal and then a number after the decimal. So we're to assume that these stems represent whole numbers and these leaves represent decimals afterwards. So for instance, this point right here would be 5.1. This point right here would be 4.6. So knowing that that's how the numbers are arranged, when it asks us to use the stem and leaf plot to find the smallest observation, we go to the very first point right here. This is the smallest observation. It has stem 2, leaf 5. So the smallest observation is 2.5. For number 8, here they give us a stem and leaf of hazardous waste with n equals 51. Really, what they're telling us is for all different states in the United States, here's the amount of hazardous waste that they get based on their ranking system. So it lists them all out by state abbreviation, and then it shows how they're organized into this stem and leaf plot. One thing that they put here that we're not used to seeing is this little marking here that tells us that they had high outliers of 87, 97, 99, and 115 that didn't fit on the rest of the graph. When they ask me to describe the shape of the distribution, what I see is in the early going, or in the left side of the distribution, if I were to flip this and look at it on its side, here we have a high bar, another really high bar, then as we move along the bars get lower and lower, and these outliers being included would get even lower. So if I look at it like it's on its side like this, so that I'm looking at it as 0, 1, 2, 3, 4, 5, 6 as the stems. At the start it's very high, and then it has a longer right tail. The shape of a distribution that's piled up on the left, you want to be left skewed, but it works the opposite of it. If the pile's on the left, it's right skewed, the skew follows the tail. Also following the tail is the mean. So if it asks me to compare the median and the mean here, the median would be lower than the mean because the longer right tail pulls the mean out to the right. But the key thing here, the shape of the distribution is right skewed. Identify the unusually large measurements by state abbreviation. So basically we have these 4 that were identified as unusually large. We now need to go back and say what states are they attached to. So I'm going to my computer just to look up my list. It looks like the first one that I can see on the list is California is 99. So I'm going to write a CA underneath that 99. I see that 87 is New York, so I'm going to write New York under 87. 115 is New Jersey, so I'm going to write NJ under 115. And the last one I'm looking for is 97. Looks like we win that one with PA. So now that I've identified each of them, if I really wanted to answer it the way that they'd asked, I'd put in New York, comma, space, PA, CA, NJ. For the thinking question, it asks us, can you think why these states have such high measurements? I honestly don't know that much about this, but my guess is they all have nuclear power plants. That's what's going to cause hazardous waste, so I honestly don't know that much about where nuclear power plants are located in the country, but my guess based on this data is that these 4 have nuclear power plants. It might be that that's not the case. It might be that this is just a measure of population density, and based on there being larger populations in these 4 states, they have more of this type of hazardous waste pollution. I honestly don't know, but again, this is a thinking question where as long as you give a reasonable response given the data, I think it's reasonable that there could be nuclear power plants in these 4 states.